Imagine a tiny fleck of paint, barely visible to the naked eye, hurtling through space at thousands of miles per hour. This minuscule piece of debris, though seemingly insignificant, travels at such high velocities that it can cause serious damage. In the vast expanse of space, even the smallest objects can become deadly projectiles. Now imagine that fleck smashing into a satellite, potentially causing catastrophic damage. The impact could disable the satellite, rendering it useless and creating even more debris. This chain reaction, known as the Kessler syndrome, could lead to a cascade of collisions, exponentially increasing the amount of space junk. This is the reality of space debris. Thousands of pieces of defunct satellites, spent rocket stages, and other fragments are floating in orbit around our planet. Each piece, no matter how small, poses a threat to operational spacecraft and satellites. Our planet is surrounded by a growing cloud of junk, remnants of past space exploration. These remnants include everything from tiny paint flecks to large, defunct satellites. As we continue to launch more missions, the amount of debris only increases, creating a hazardous environment in space. From spent rocket stages to defunct satellites, this orbital debris poses a significant threat to our current and future space endeavors. The debris can collide with operational satellites, space stations, and even crewed missions, endangering lives and critical infrastructure. What was once the pristine frontier of space is slowly becoming a cosmic junkyard. The accumulation of debris not only threatens our technological advancements but also the safety of astronauts and the sustainability of space exploration. The consequences of inaction are dire, jeopardizing our access to space and the vital services it provides. Communication, weather forecasting, navigation, and scientific research all rely on satellites that are at risk from space debris. If we do not address this growing problem, we may find ourselves unable to safely operate in space, hindering progress and exploration for generations to come. Space debris, simply put, is any human-made object orbiting Earth that no longer serves a useful purpose. This debris can range from large, defunct satellites that have outlived their operational lives to tiny fragments of paint that have chipped off rockets and spacecraft over the years. This includes everything from large, defunct satellites that once provided communication or weather data but are now just floating relics of past missions, to tiny fragments of paint chipped off rockets, which might seem insignificant but can cause serious damage due to their high velocities. The vast majority of this debris resides in low Earth orbit, the region extending up to about 1,240 miles above Earth's surface. This area is particularly crowded because it is where most satellites operate, including those for GPS, weather forecasting, and international communications. The problem is, objects in space don't just disappear. Unlike on Earth, where gravity and atmospheric conditions eventually bring objects down, space debris remains in orbit for a very long time. Without the resistance of air to slow them down, these pieces of debris continue to circle our planet at incredible speeds, posing a constant threat of collision. Even a small piece of debris traveling at speeds of up to 17,500 miles per hour can cause catastrophic damage to operational satellites or even manned spacecraft. This debris can remain in orbit for decades, even centuries, making space a progressively more hazardous environment. As more and more objects are launched into space, the risk of collisions increases, leading to a potential cascade effect known as the Kessler syndrome, where each collision generates more debris, further increasing the likelihood of additional collisions. This makes managing and mitigating space debris a critical challenge for the future of space exploration and satellite operations. The danger posed by space debris is not just theoretical. Even small pieces of debris, traveling at high speeds, can cause significant damage upon impact. A collision with a defunct satellite could cripple a functioning one, disrupting crucial services like communication, navigation, and weather forecasting. As more objects are launched into space, the risk of collisions increases exponentially, a phenomenon known as the Kessler syndrome. This cascading effect could create a debris belt so dense that it would effectively trap us on Earth, preventing future space exploration. Recognizing the growing threat, space agencies and private companies are developing innovative technologies to tackle the space debris problem. These efforts focus on two main strategies: removing existing debris and preventing the creation of new debris. Removal technologies range from robotic arms and nets designed to capture large objects to lasers that can nudge smaller debris out of orbit. Preventing future debris involves designing satellites with end-of-life disposal plans. such as deorbiting mechanisms or propulsion systems to move them into safer orbits. Section 5. A sustainable future in space. Addressing the space debris problem requires international cooperation and a long-term commitment to sustainable space exploration practices. This includes developing stricter international regulations for launching objects into space and mandating debris mitigation measures. Investing in research and development of advanced debris removal technologies is crucial. Furthermore, fostering a culture of responsibility among all spacefaring nations and commercial entities is paramount. Only through collaborative efforts can we ensure a future where space remains accessible for generations to come. Section 6. The time to act is now. The issue of space debris is a stark reminder that our actions have consequences, even beyond our planet. The debris orbiting Earth is a direct result of human activity, and it's our responsibility to find solutions. We are at a critical juncture where inaction could have irreversible repercussions for future generations. The future of space exploration, and indeed our ability to benefit from the invaluable services provided by satellites, depends on our commitment to addressing this issue. We must act now to ensure that space remains a resource for discovery, innovation, and progress. Section 7. Beyond the essay, exploring more. This essay has provided a glimpse into the complex and pressing issue of space debris. To delve deeper into this topic, I encourage you to explore the wealth of information available online and through various educational resources. Understanding the problem is the first step toward finding solutions. From the technical aspects of debris mitigation technologies to the international policies governing space activities, there's a wealth of fascinating knowledge to uncover. Engaging with this information empowers you to contribute to the conversation and advocate for responsible space exploration. Section 8. Join the conversation. The challenge of space debris is one that affects us all. Every piece of debris, no matter how small, poses a significant threat to our satellites, space stations, and future missions. As we continue to explore and utilize space, the accumulation of debris becomes an ever-growing concern. It's not just a problem for scientists and engineers, it's a global issue that requires collective awareness and action. Share this video with your friends, family, and colleagues to raise awareness about this critical issue. By spreading the word, we can educate more people about the dangers of space debris and the importance of space sustainability. Imagine the impact we can make if everyone understands the gravity of the situation and takes steps to address it. Let's start a dialogue about the importance of space sustainability and inspire action. Conversations can lead to innovative ideas and solutions. Whether it's in classrooms, workplaces, or community centers, discussing space debris can spark interest and motivate people to contribute to the cause. We need to foster a culture where space sustainability is a priority. What are your thoughts on the space debris problem? Have you ever considered how it might affect our daily lives and future generations? Reflect on the potential consequences and share your insights. Your perspective is valuable, and by voicing your concerns, you can help shape the conversation and drive change. What solutions do you think hold the most promise? From advanced tracking systems to innovative debris removal technologies, there are many potential ways to tackle this issue. Share your ideas, and let's explore the possibilities together. Collaboration and creativity are key to finding effective solutions. Share your opinions and ideas in the comments below. Engaging in discussions online can connect you with like-minded individuals and experts in the field. Your input can contribute to a broader understanding and help build a community dedicated to solving the space debris problem. Let's work together to ensure a future where space remains accessible for generations to come. By taking collective action,